Devices. There's going to be a lot to unpack here because this is really where locations, media players, and their linkage get built up. So if we're going to go, let's go back for a second to talk about the inheritance of configuration in scripts. I just want to take it backwards from a script and get to the containers that we're going to be working with here. So remember that in a script, you assign zones. Zones are containers for groups. Groups are containers of locations. And locations are really containers for a DMP, right? It's a one-to-one map, one location, one DMP. This is where all of that linkage happens. When a device first comes on the network, when you plug in a DMP and it automatically registers, it will show up in the configuration page here as a DMP type object with a name of auto and its MAC address. These represent DMPs that have come online in the system and have said, I'm present, I'm configured, I'm ready to be assigned to a location. A DMP without a location assignment doesn't really have any pertinent configuration information relative to its group and zone structure, relative to the device that it's connected to. You have the ability to monitor a DMP that is not associated with a location, but most of the stuff that you would typically think about using Cisco Vision to control, you can't control until it's assigned to the location. So you'll note that there are three types of objects that we see in this location DMP tab. We see DMPs, which are registered devices. Typically they'll either have the name auto or they'll have the name unassigned. Unassigned usually refers to a DMP that was a part of a location that you've unlinked from that location, meaning that it's ready to be assigned to a new location. A DMP plus location, which is an object that contains location information and an associated DMP. And then you'll also find just locations. So if we sort by type, which will take a moment because there are many DMPs, you'll see that there are locations that are not explicitly associated with a DMP, like these performance venue locations. The process of linking a DMP to a location can be done in the location DMP mapping tab. Because every DMP is identified uniquely by its MAC address, we can simply select the MAC address of the player in question, select a location that we want to link to it, and hit this link button. Once we do that, the DMP will become associated with all of the programming information relevant to that location. In order to get the configuration change to apply to the media player after you link it to a location, that media player does need to be rebooted. So just make a note that anytime you've completed a link on a new DMP, you do want to reboot that player just to make sure that it gets its configuration. You cannot link a DMP to a location that already has a DMP associated with it. And you can tell that pretty easily if you look at this list on the right. If there is an assigned device and a location name, that device already has a link. If we scroll down, actually we'll use the performance venue again as a reference point. So this would be an example of a location that does not have a linked DMP, which means we could go over to our list on the left and we can hit our link button. In fact, I can do this because we'll break this in a couple of seconds, but you'll notice that 4065, when the list reloads, now has an assigned device. If we were to reboot that device, it would receive all of the configuration associated with that location. And as we go through the configuration tab, one of the things that you're going to see is there's a lot of information that gets associated with a location. The location's really where all of the configuration lives. If you want to unlink a device, simply hit the unlink button and it will do the opposite of what just occurred. If we go back to our location, we'll see that we no longer have an assigned device. So taking a look at locations in DMPs, we can see the information that's pertinent to the device, a quick view on the right-hand side once you select the device. It'll show you the name. A DMP won't come up with a description initially, so that field is not really relevant, but it will show you the IP address, the MAC address, and its current state and model. A DMP plus location will show you a good deal more information. It'll also show you the display spec, which is really the most important piece of the configuration on this page. The display spec, which we'll get to further down in the device configuration tab, is the container for all of the information about an attached TV or display of some kind that the DMP is going to be sending content to and controlling. To get a detailed view of all of the configuration for a particular device, you can hit the Edit tab, which will show you a breakout of the information that you saw on the right that is editable. So here, if you needed to modify the display spec for a particular DMP and location object, or just a location, go to the display spec. A drop-down will show you everything configured for your environment, and you can select the model of TV and hit Save. Much like with associating a DMP to a location, if you've got a DMP location that are linked and you change the display spec, the DMP does need to be rebooted before it takes the configuration change. So just make note that if you change the display spec associated with a location, always reboot any linked players.
If you needed to add a display spec and create a new one, or would you do that?
We're going to get there.
Okay.
It's 2 tabs away. We're very close. And then just to show you an example, most of the same information that you see in the DMP plus location on this tab, you will also see on just a location. So if we just go to PV, you'll notice that we no longer have things like MAC address or IP address because there's no associated player, but you do have the name, description, location ID, and display spec. So if you're planning an expansion, like you're adding a number of DMPs, typically we would handle that by adding in new locations for all of the expansion, and then once your DMPs come online, you associate the new DMPs with the locations that have been created in the system. Couple of other things I want to show you here before we move on. There is a method for doing bulk changes to Cisco Vision through this menu. It's extremely useful for making large numbers of changes, but I would recommend being very cautious about using these tools because powerful tools can often cause major issues if they're not used carefully. The import and export buttons will allow you to grab a comma-separated values file of all of the current search in this window. So right now, we have the PV selected. We're going to do an export. It'll take a moment, show you the number of records, and it will download as a file. Using a spreadsheet editor like Excel, we can open that file and actually see what that database looks like. Much like with the punch list exporter that we talked about in the device manager, if we continue along, this is a tab-separated values file as opposed to a comma-separated values file. So our delimiter here is a tab. Once we've identified that all of the rows are broken out the way we expect to, we can hit Finish and take a look at what we have going on. This field actually contains a lot more information than the Location and DMPs tab actually shows you. It will show you not just the device type, its MAC address, its IP address, its name, but it will also show you things like luxury suites that it's currently associated with, the logical ID and the name of the TV type, the production status. And if we continue to scroll further to the right, it'll also show us the groups that that device is enrolled in and if there is any venue associated with it. Some, but not all of these fields can be updated with a bulk import. A couple of things to note. You can add a device to a group by adding that group in this column, but there is no method for bulk deleting a device from a group. So if you were creating a new group, you could add that group here. If it's a group that does not currently exist in Cisco Vision, that group will be created by Cisco Vision and the device is added to it. There's no way to do a bulk upload of groups associations with zones. You can simply add a device to a group here. If you choose an existing group, it will just add those devices to that group. You can make a couple of other updates. The name can be updated. The process for that involves using the old name in the old name column and then providing new names for your display, etc. Now, in order to make an update, you need to set the operation type The operation type is either create, update, or delete. If you put delete here, it will 100% just delete the location, DMP, or whatever row you've associated with. If you're trying to add a net new location, you do that with the create tab. And if you're just trying to make a change to the existing configuration, you do that using the update operation type. A couple of things. If you have an entry type that's a location, you can't update it to a location with DMP or to a DMP. You would have to delete it and re-add it. If you're creating, you can fill in 100% of these categories, and most of them will propagate. The entry type, MAC address, IP address, name, model, location, state, description, TV type, and scripts and venue associations, groups and venue associations. These can all be added manually. You cannot add a device to a luxury suite using this method. So, any questions about the bulk import tool? Typically what I would recommend, especially if you haven't used this tool before, I would recommend that you do a full export of your entire database, because you can just re-import it if you need to, if you make any mistakes. It's incredibly useful just to maintain a backup, and this way if you needed to just wipe everything and then re-add it, you could do so. Once you have that CSV created and you're ready to do your import, all you have to do is click on the import button and select the file. Just as a note, when you save that file, you do want to keep it as a text file, whatever the file name is, .txt. Because if you change it from a tab-separated values file, the system will no longer be able to read it. When you import, it will actually tell you which devices were successfully changed or updated, and it will give you another downloadable CSV file that has the individual entries that failed to import and the reason that they failed to import. As a note, location DMP mappings can also be done using a bulk editing tool. In this case, when you do an export, there are only 3 fields in use. The MAC address, the location name, and the location ID. In order for a bulk import of DMP location linking to work, the location does have to have an assigned location ID. It is possible to create a location without a location ID, but if you don't have both of these things correct, it won't actually import correctly. In order to do this mapping, all you have to do is take your existing locations that you want to map to, and then add the MAC address for the associated player in the column on the left. Once that's saved, just like with the bulk import tool for devices, you can just hit import, and it'll do that linking automatically. IP phones I'm going to talk about briefly. These really don't pertain to either the SoFi or the Raiders environments, but Cisco Vision does support some connectivity with Communication Manager. Specifically, the model 7975G IP phone can be used to control DMPs. If you wanted to add an IP phone, you give it a name, description if you want to, an IP address for the phone. Port is typically all 7s, security is 0. You don't have to enter in a MAC address, an admin ID, or a password, typically. And then you can select either a luxury suite or an admin office. The remaining device types are typically not used. Once this phone has been created in Cisco Vision, it can be associated with a luxury suite as a controller, in the same way that you could associate a third-party controller with legacy API calls. Local control functions very much the same way. It uses the same control mechanism that the IP phones do, which is not the current API that's mostly used for Cisco Vision control. But if you have a legacy third-party control device, you add it here, just like with an IP phone. You give it a name, give it the IP, whatever port that device is communicating on, and if it requires a password. Again, local control devices and IP phones become visible in the luxury suite configuration. So I'll show you where those would pop up if you had to configure them. Okay, and the moment that you've been waiting for, display specifications. So display specifications are where you configure control specs and output specs for particular TV types. As a best practice, I recommend having an individual display spec for every model of TV in your facility. It's useful for a couple of reasons. One, you know what the type of TV is at any given location just by doing a search in Cisco Vision, which can be really useful just for identifying, okay, is this a TV that we know has a known issue from a firmware perspective? Is this something that we know typically has an issue on a particular HDMI port? It's just aggregating information so that you can respond really quickly, even if you can't get physically in front of the TV. The other piece is that individual makes and models of TV do have quirks about either their control plane or their output requirements. In this case, the SoFi environment is predominantly Samsung displays. So we can look at each model of Samsung display because we've created a separate independent display spec for each one. If you'll note on the right-hand side, we can look at the parameters associated with that display spec. So it has a device name. That's the one that shows up here. And the device name is also, by the way, the string that you would use in the bulk importing tool if you were going to associate a location with a display type. That's the value that you want to include. Description, you can provide additional color. So in the case of Samsung, there are two different control mechanisms. I typically identify which of the two is used by a particular display type, either X-Link or non-X-Link. That may not matter depending on your venue or the vendor for the TVs, but it's worth noting. Make, Samsung, model number. We can talk about volume strategy briefly here. Volume strategy is a question of whether or not the DMP is expected to be the audio source from an amplification perspective or not. Internal volume strategy says that the DMP, when you send volume up and down commands, sends them to the volume of the DMP internally. The default volume for a DMP is set for both left and right channels to 50. If you recall, when we were discussing the device management tab, there is a volume control that can be pushed out to a DMP that changes either the left or right volume. It's a scale from 0 to 100. 50 is typically called unity gain. The recommendation is if your TV has RS-232 controls for volume, internal volume is not usually the correct strategy. The recommendation is external volume control, which means that when we send volume control commands out to the TV, we're actually sending RS-232 commands. We're telling the TV to adjust its volume up and down, which means that the gain control for that TV type is happening at the TV and not at the DMP. In that strategy, the DMP's volume internally stays at 50. The third volume control strategy is none. If none is selected, the DMP does not pass audio on its ARC channel or on its analog audio port. This would be if you were feeding a confidence monitor that had no audio output. In most cases, you're going to be using internal or external for one reason or another. Separate from basic info, we have the display parameters tab. The display parameters tab is a little bit dense, so we're going to take a little bit of time to unpack what we're actually looking at here. Some of the display parameters are very self-explanatory, things like on, off, input, etc. What you see on the right-hand side is an RS-232 hexadecimal string. That's the control string that you send to a DMP, out the DMP's RS-232 port and into the television in order to control whatever parameter on the TV we're attempting to control. This is going to differ based on vendor for sure, but also sometimes from models. Like in the Samsung example, there are two control methodologies. MDC, which is typically used for like their commercial style displays, and X-Link, which is used for most of their standard in-home displays. You have a mix of both in your venue, so you'll see that if you look at devices that are tagged for X-Link or non-X-Link, these codes will differ. It's important if you're adding a new display type into your venue that you identify A, does it support RS-232 or HDMI CEC? And if it does support RS-232, can we get a copy of the hex commands to actually send these controls out to the TV? Really important, just a physical cabling issue. There is a serial port on the DMP. I'm going to try and show this to our folks at home. Right here, the front. Hopefully we're in focus. But this serial port is where you connect an RS-232 cable. On the DMP, it is a mini TRS that is an 1/8 inch tip ring sleeve jack. It's exactly the same as a standard headphone jack. It has a transmit and a receive on the tip and the ring. It's actually crossed over so that if you connect a standard headphone cable from a DMP into a TV, typically the receive and transmit are lined up correctly. For some display types, and it depends on the display type, you may have to add a crossover into that cable, which swaps the tip and the ring on either side. That requires testing on a per display basis. If that cable isn't plugged in both to the television and to the DMP, messages will not pass. It's typically the first troubleshooting step if you have an issue with controlling a device. The second troubleshooting step is to take a look at the display specs, right? What we have right here. Now, as I think you may recall from our discussions about the device manager, you can directly send an RS-232 command right out the port into a television from a DMP. So a good way to check that your display spec is working correctly for the assigned location is to go to the display spec that's been configured for that device, grab a copy of that hex string, and then send it using the command in the management dashboard. If it responds to the command, then you typically have good cabling and it's functioning the way you would expect. There may be something else that's blocking your ability to send a command out. Now, as I mentioned before, implementation of the RS-232 standard varies wildly across vendors and models. Not every display is going to support all of the commands that you see here. But typical commands that you see configured are power on, power off. Mute is a fixed mute command. That is a turn mute on, as opposed to a toggle, which when you hit it, either turns it on or off depending on its state. Samsung supports a mute toggle, not a fixed mute unmute. Input 1, 2, 3, and 4. Those are just the ones that are supported by Samsung. Cisco Vision does not allow you to add additional inputs. So if you need more than 4 via RS-232, there's no real good mechanism for doing so. I have sometimes used unused parameters and just added the RS-232 code to that unused parameter just to get an extra input. So like for example, fixed mute isn't used in Samsung. If you had a 5th input command that you needed to use, you could hypothetically assign it to mute and then use a script state that pushed the mute command out to script that activity. Careful of that because you probably need to make sure that that's documented. It's very easy for that to turn into errors, especially if you have more than one person who's actively in the configuration of your system. Startup commands, you can actually send a series of RS-232 commands and put them in here as a long string, which basically says when we want our TVs to come on, we want to set them to a particular volume level, we want to set them to a particular mute state and a particular input. So we could add separate strings. So I'm going to take, for example, our on. We'll add save. And then maybe we want to set this to input 2 as well. So we'll take this string. We'll add a second string. And then perhaps we also want to toggle the mute function. and now we've created a startup command. That is a set of commands that can be scripted. Again, just like all the rest of these, if you find in a script state, when you go for power on, for example, instead of just sending a power on command, you could send a startup commands via the RS-232 action in a script. For now, though, we're going to back those changes out, revert back to our original. Input names. So these are just how you can clarify what each input actually is on a particular TV. So in this Samsung model, these 4 inputs are all HDMI. HDMI is 1 through 4. That may differ, again, depending on the display model and the vendor. The items that you see here, the display power query, power on response, ACK response, and echo response, these are bidirectional response commands that the DMP expects to get back in the event that the TV is providing information about how it responds to an outbound RS-232 command. In other words, if you send an on, we want to be able to say, okay, we've received an acknowledgement from the TV that on request was actually received by the TV. Again, many display manufacturers don't support these types of codes. In the case of Samsung, they don't, so they're not configured. But it is useful to be able to identify the current power status of a TV. So if you have a display type that supports one of these query commands, typically it's recommended to try to configure it if possible. Again, mute toggle does what you would expect it to do. Whatever the current mute state of the TV is, it moves it to the opposite. If the TV is currently muted, it unmutes. If the TV is unmuted, it mutes. Disable, this command is to disable the on TV buttons. Some TVs support the ability to turn off local controls. Sony is a good example. They have a hex command that says disable all buttons on the TV. If it's configured for, if it exists in the display's RS-232 spec. So for Samsung, it's not an available command. Yeah. These are all things that can be configured if the display supports it. And that's the important thing to remember. The display has to have an RS-232 specification that supports these commands to configure them and get them to work.
I don't say because some of these TVs are so close to the framing that
yeah.
around the display, so sometimes that power button is getting pushed.
Yep.
Or the volume button.
Yep. Or, you know, a cart smashes into the corner of a TV and breaks. Yeah. Low-hanging fruit can be a problem in a venue. So yes, this is also a good note for those of you who will end up going out and shopping for replacement displays at some point in your venue's lifespan. Looking at the kind of serial commands that your devices support, and like having a use case, like saying, we really want to make sure that these TVs that are going to be customer facing or close enough to touch can be disabled. You have to find a vendor in a model that supports that command to make sure that you can accomplish what you want to accomplish from a serial control perspective. The volume, the individual numbered volumes apply to devices that have specific RS-232 commands that set the internal volume level. Samsung does not. We've talked about the fact that Samsung volume controls are iterative, so it's just up or down. But Sony is the example that comes to mind. Sony have explicit volume level commands. You can set a 1, a 2, a 3, a 4, etc. DMP serial delay. This is the number of milliseconds that the device locks out a second command after you send the first command. In other words, when you send a mute toggle, there's a period of 250 milliseconds where the device will not respond to a second incoming command. It's actually a thing that can come up sometimes from an API perspective, and we'll talk about that later, where if you want to send a variety of commands back to back, you'll get back an error saying you're still within that 250 millisecond period. The API is smart enough to send you that error. If you're sending these commands to the dashboard, you have to either look at the display spec to confirm that for yourself, or just anecdotally, be aware that you should be waiting, a second between commands. Relative volume steps. For an external volume control display that uses a volume up and volume down, That is the number of times that command gets sent to the DMP when you hit volume up on a control page, or if you send a volume up command using a script state. So for example, in Cisco Vision Plus, and we'll get to that later, the volume up button sends the volume up command 5 times when you hit the button. Video wall on and off. This applies if you have MDC style devices that have a video wall presentation mode. Typically, it's like a cascading display where the upper left-hand corner is the lead. That's what gets the input from a media player, and it may or may not have the ability to just cascade across all of the other displays. That very much depends on your video wall configuration. At Raiders HQ, for example, your video wall has a dedicated, you've got a dedicated DMP behind every location. You would never need to use a command like that. And you use predominantly TV1s as your pass-through, so not necessarily pertinent, but at Allegiant Stadium, though, there are actually devices that do support MDC in the video wall configuration. So that does have some pertinence in your environment. SV 4K video mode. This is a really important display parameter. This is where you can fix an output resolution for a DMP. If you know that you have an attached device that you absolutely have to have negotiate to 1080p 5994 or 4K 60 frames per second, this is where that gets configured. One really important note is there are a fixed number of display and output standards that the DMPs will support. The formatting for this, we'll actually go to a good previously configured example. So if we look at a 1080p configured device, SV4K.video mode is set to 1920 x 1080 x 60p. These strings are explicit because they're looked at by the bright sign hardware in order to identify what the output standard looks like. We can see the difference between a 60p 1920 presentation and a 1080i, the difference here just being the letter. 5994, 24 frame, 30 frame, all of those output standards are all supported by the DMPs. You just need to make sure that you're explicitly using the appropriate string. You can look up the documentation for a Cisco DMP. It'll show you the ones that Cisco officially supports, but any string for an output resolution that BrightSign supports, typically you can enter into this configuration. It will work the way you expect it to. There are a couple of differences. So a couple of notes. It is possible to force a DMP into YCBCR or YUV output, but it does require a little bit of additional work on this configuration. Again, the color space encoding should be set to either 422 or 420 at either 10 or 12 bit. This is supported for 4K outputs, but it does not appear to be supported on Cisco DMPs for 1920 outputs, at least on the current firmware. So if you have broadcast applications where you're inputting a feed from a DMP, just be aware that this is a constraint. Jump back into our 7075. Baud rate, some serial interfaces do require an explicitly set baud rate. Again, you'll have to refer to the documentation for the RS-232 standard for the display that you're attaching and configuring, but that's not typically required for most deployments. Input query and input response, again, these are return channel RS-232 commands that allow the DMP to receive back a confirmation of what input is currently tuned on the display. Monitor API delay, again, this is just the freeze out time between API commands during which the server will issue an error indicating that a second command can't be pushed. This is set to the system default in most cases. If there's an application where you need the response time to be faster, this can be tweaked, but typically there will be a lower bound after which additional commands will create conflicts. So it's recommended to keep this the system default unless there's an application-specific need to reduce that lockout time. Now, if we continue down to the other important pieces are the power query by CEC and TV control by CEC. In the event that you have a display type that you wish to control via Cisco Vision that does not have serial command access, you do have the ability to use standardized HDMI CEC controls over a single HDMI cable. The same one that carries your video signal will also carry command and control. In order to set this up, all you have to do is go to the dmp.tv control by CEC display parameter, set the value to true in all caps. No, just lowercase is fine. Once that's set and the DMP reboots, it knows to send out its commands via CEC instead of RS-232. Same thing applies with Power Query. This allows you to return Power Query information over the CEC channel. DMP supports touchscreen. Essentially what this does is takes the incoming USB port on the DMP and prepares it to accept the output of a digitizer. So if you have a touchscreen display that you expect somebody to be able to interact with, for example, a touchscreen website, this is a way that you can take in an input from a digitizer into a DMP to allow user interactivity with that device. HDMI streaming delay, that's just the buffer time that's associated with the player if you were to use it as an encoder. And again, that's time in milliseconds. VSync delay and sync delay are typically not configured. DMP.portrait. This is used in order to rotate the display from a landscape to a portrait device. In order to set this, you either set the DMP.portrait value to true, which will tilt the device minus 90 degrees, or if you're attempting to move it in the opposite direction, you can set, you actually have to create a new value called dmp.portrait.clockwise and set that value to true, which will rotate it in the opposite direction. This is documented on Cisco's site, but it's a little strange to look at. But at the end of the day, you just have to identify what direction a portrait DMP actually needs to be configured and set up a display spec based on the explicit rotation that's required for the location. PCR mode, again, it's whether or not it's using primary control rate information. 0 allows the PCR data to be fed by an encoder, and that's the system default. You typically wouldn't configure this. Layer order mode refers to the order in which HTML content is rendered. This is new to 6.3. I haven't really played with this a lot myself, but it does apply to the menu board deployment for SoFi, so it does have some relevance. Typically, any video region that you add HTML content to prior to 6.3 always rendered the HTML content at the front of the Z ordering. In other words, it didn't matter where you put it in the template. If it was a web page, it pushed itself to the front. This layer order mode allows you to change the default behavior of where HTML content is rendered. Off the top of my head, I haven't configured this enough to know the strings that apply, but you can essentially say render it in the back of the content, render it in the center of the content, or render it in the front of the content. And those strings are can be found in the release notes for Cisco Vision version 6.3 if that needs to be configured for your environment. And that is all of the display parameters that we set up in a display spec. So overall, questions about display specifications or parameters?
Could you jump back to the Q7055 default one?
Yep.
And then if you scroll down to the TV control by CEC.
Oh, I'm going to change that back.
Yeah, I was going to ask, so it seems like whenever you change these settings, it's instantly saved, as opposed to other things where you have to click the physical save button.
So you'll actually note that it's that you have to save the command. When you save the command, it writes the command to the spec.
So you don't have to
Right.
hit save again like you would in the script right now.
Correct. It's not 2 confirmation steps, it's just 1.
Yeah.
So when you're in the parameter, if we go to mute query, I add some text. Once I hit save, that writes immediately.
Got it.
But keep in mind again, this is just changing the configuration on the Cisco Vision side. Until you reboot the associated players, the changes aren't going to propagate out. So with a display spec, order is you make changes, save the changes, reboot your DMPs. And that applies whether you're modifying your display specification or changing the display specification on a DMP. In either way, if there's a change that gets made, if the player doesn't reboot, it won't get the change.
For P42, we have the touchscreen enable and disabled option, right?
Correct.
How do I know which one's enabled right now? I know the disabled is active right now.
Yes. So that's, again, a part of the DMP configuration. So let's go and look at locations in DMPs. We'll pull up a P42. Just for clarification for the folks at home, this is an LED-based site signage application. So on these P42s, we can just pick any of them, and you'll see that the display spec assigned to that location is touchscreen disabled rotated. So if you wanted to re-enable this, there are two ways that you could do it, and I think we've talked about this before, but you can either edit one by one, where you go into that device, move it from disabled to enabled, save, and then rotate. Or you can make that change from the bulk updater. And I'll show you what that looks like in 2 seconds. So we'll just change this back. Saved. So if we go into this bulk export again, so you see here where it says TV type, right? So let's actually go down to a P42. Oh, I don't have an export for it. Let's actually do this correctly. We've got these P42s. We're going to do an export of just the P42 locations. So if you follow here, we've done an export. We have 38 records. We're going to open that P42 record. And now, where it says P42, where it says a TV type, if you change that to enabled, I'm just going to copy down the string. I can take all of these, change them to enabled, and then I can do an update operation. So if I save this file and then I re-import it here under locations and DMPs, it'll change all of those devices' display specs to the one that you want to move them to. And you can select which ones if you, let's say you didn't want to do that group. If you import a bulk file that has nothing for the operation type, it'll ignore those entries.
Sounds good.
Yeah.
And just for the programming of the specification itself, it's a simple matter of going into the display parameter and just disabling the touchscreen field or something like that?
Yeah.
True or false?
Yeah, and I'll show you again in the P42 sign type. So if we look at your spec for the P4.2, so you've got two right now. You have an enabled and a disabled. But you'll see supports touchscreen on the enabled is true. And if we go to our disabled, we're false.